The clusters philosophy.
Also, that's in the two different divisions. So you get economics and social sciences. Oh.
YouTube. We love YouTube.
Okay, we'll catch up in just a second. So we're going to talk about databases today. And so the critical thing is to think about when you need a database instead of a spreadsheet, because most of the time, I'm sure most of you have used things like Excel spreadsheets to organize some things, something like Google Sheets. And most of the time those are perfectly adequate, especially if kind of you're the only one working on it. But sometimes for a larger organization, when there's more people working on it, or you're entering just a ton of data, a lot of the problems that would pop up trying to use a system organized around spreadsheets can be fixed by using a kind of a database, which it takes a little bit longer to get set up and necessarily learn how to use it, but it prevents a lot of mistakes down the line that can really cost the organization a lot of time. We'll get into some of those. So what is a database? It's going to look an awful lot like spreadsheets at first, because we've got, it's just a way to store the data. It's made up of tables, which are going to be a lot like the tabs in an Excel spreadsheet. Fields kind of correspond to columns. In fact, sometimes I might call them columns. Records are going to be rows, and I may call them rows. And so those are going to be, that's the main terminology of databases. The thing that is really going to set them apart is that they have a lot more structure than a spreadsheet. So while you might have a column on your spreadsheet that says that it's like a specific date, there's nothing actually in Excel forcing you to enter dates there. And so if somebody makes a typo sometime and enters something that's not actually a date or something like that, and you don't catch it right away, by the time you notice that there's a problem, nobody might actually know what's supposed to be there, and you might just lose all of that information. And there are things more significant than that where it can become a bigger issue. A customer ID number is like one digit off, and you have no idea what customer that was, or you accidentally overwrite something for a different customer because you think that that's them. So all sorts of things can happen. So databases introduce a lot more structure. So a column will have a type. And so if you try to put something in there that isn't the right type, it'll reject it. So if you try to put like characters like A, B, C, D in a column that just is only allowed to store numbers, it's going to tell you right away like you can't do that, and you'll know when you tried to submit it that it didn't work. So you can fix it while you still know the correct answer. It also can have rows that are required to fill in. Like, so if you have a spreadsheet, you might have rows and not put in like critical pieces of information, or have those critical pieces be invalid. And you might not come back to it for a long time after that and realize that you needed that, or the person entering it might not know that that was required. Like, they might not know quite what the field is, they might be new, and so you, like, if they don't put something in there that you needed, all of the work is gone. Whereas if you have a database, the database knows that that field has to be there and what sorts of things can go there, and so it helps correct for those sorts of mistakes. It won't let in when they try to submit the record to store it there. It will say, like, this field is required. In fact, you've probably seen it on web pages. Like the web page, you're filling out the form and you try to submit, and it tells you, required field left empty, or that it's not valid, and you have to go fix it. That's exactly the sort of thing that the database does for you. And the other thing is that they can have references to other tables. So you might have like something in a sale that says a customer ID number, and you assume that in your table of customers, you have something that has that ID number. In the spreadsheet, you could be wrong about that, whereas the database will actually go check and make sure that there is a corresponding row there like you are referencing an actual customer and you didn't mistype the number. Well, you could mistype the number, I suppose, if you specified a different customer, but there's no way it can catch that. You told it the wrong thing, and you told it something that was valid. And so those are the big things that we'll look at there. It's going to change in just a second. I've got to get used to the lag. I have to tell it to change a little bit early. Okay, so the best times to use a database instead of spreadsheets are exactly when all of these problems are going to be the worst. And so when you're going to be storing it and dealing with it over a long time, that means like lots of new people are going to be involved with it at different points in time. It's probably not just going to be you that works with it. And so somebody might be coming along later, entering in data that didn't know what you meant when you first created the spreadsheet. And you don't want like a million copies being made. And so the longer something is around, the more it tends to get confusing. In fact, the more you tend to even forget why you made stuff, let alone figure out why somebody else did. Other thing is, when they get to be too large, it's really slow to open them. If you've ever opened like some ginormous Excel spreadsheet that has like 50 tabs and a ton of stuff entered on every page, it can take your computer forever to look at any of the data. And so that can really be a problem if somebody's computer can't handle the spreadsheet that you made because your computer's faster than theirs. As I said, like relationships between sheets and fields are complex. So if you have a lot of places where, like as I mentioned with the customer ID number, you're like referencing other pages all over the place. The more of that you have going on, the harder it is to keep track of. And so having like a firm definition when you made the database is a lot easier to keep track of. And again, many people will be working with the data. The more people are involved, the more chance you're going to have somebody entering something that doesn't know quite what's going on. And so the more you need, first off, the easier it is to be entering it, because even as nice as Google Sheets is, I'm sure if any of you have ever like quickly received an email that has you signing up for stuff, it can be just chaos in the first minute that people are in there trying to sign up for stuff because there's people editing the thing all over the place. And so this kind of fixes that, because you don't see what everybody else is doing. You're kind of just like, okay, I want to put this in there, and then it does it. Usually through forms. So usually through like filling out a form like on a web page or an application, and then just submitting. And so this is going to be a bit overwhelming. We're going to talk about, I mentioned before that like the columns have various different types, and they have to be one of a number of types. I'm putting up a list of every type that's supported in Microsoft Access. The bold ones are the ones that are more commonly used. The other ones are just there for information. So text, that's going to be any letters or numbers or just anything that's kind of arbitrary, anything that you can type. The standard one is text, which is limited to 255 characters. Usually they're used for things like addresses and stuff like that. And so they don't have to be terribly long. If you want to put something longer in there, like a full document, you'll need something like the memo. Memo, which is less commonly used. Then for numbers, if it's going to be an integer, you usually want to use the integer type. You can use a long if they're going to have particularly large numbers. I'm sure that that's probably how YouTube has stored its view counts and things like that. But for the most part, if your numbers are going to stay reasonably low, below 32,000 or so, an integer is fine. And then for decimal numbers, you have quite a few different options. You'll probably want to use double if you are just storing numbers for like scientific reasons or to keep track of things. Currency is really specific to money, and it's because for applications like banks, rounding errors with cents can be a huge problem, and so it isn't necessarily always more accurate than double, but it does a much better job of keeping track of making sure you don't have rounding errors in your cents that can cost large companies that are processing millions of transactions a lot of money over time. So that's the specialized thing. If you know that it's going to be specifically money, like the sale price of an item, currency is the type used there. Auto numbers are used as ID fields. So if you need something, you don't care what the number is. You just need a unique number for each of something, whether they be customers or items. Using an auto number can be really beneficial, because that means when you're creating something from a form, you don't have to say what its ID is going to be. You just say, okay, I want to make a new one, and it automatically picks a new number for you and make sure that that number wasn't already there. And usually they, when possible, make sure that the number has never been there. So like if you so like with customer ID numbers, it would try not to give you an ID number that belongs to a former customer. In the case of things like social security numbers, they do recycle, but that's the sort of ID. And then the other, they're mostly pretty straightforward. Date and time and simple yes or no are the most common ones. You can do fancier things like look up wizards with drop downs like for what type of employee you are and things like that. But they're all here, and they're also at the end. There's a series of references, and they're all linked there as well. And so then we're looking at kind of the organization of how these tables all fit together, because if you just have a series of completely disconnected tables, you could actually probably get away with a spreadsheet unless you really have complicated things that you're needing to store. We talk about primary and foreign keys. These are kind of how you reference things in your table and in other tables. And so I mentioned customer IDs. In this table here, we've got customer IDs 1, 2, 3, and 4. So these are that auto number thing. They're designed specifically so that everybody gets a unique number, just so that we can keep track of them. As long as you know that like you've got your like customer table, and you want you can keep like a unique permanent identifier to a particular customer just with that one number. And so they're using that here to say they've got this orders table, and so the orders have their own IDs, and they've kind of got a date that keeps track of when it happened. But then they kind of separately they point to which customer did it. So rather than having to like store all of this information for every single transaction, they just say, okay, it was customer 2, and if you want to know anything more about that customer, you just go up here and look it up in a separate table. And so it helps tie together the tables. The thing that ends up being better about doing this in a database rather than a spreadsheet is, again, when you tell it that the customer that made this order was customer 2, it will check and make sure that there is a customer 2. Because otherwise it's going to say it's an invalid foreign key, like the customer that you just told me doesn't actually exist, like enter another one. And so that can be helpful, especially later on when you, like for instance, or deleting customers and things like that. It might say, okay, well, like you can delete this customer from the active customers table, but like they need to stay around because we're still referencing them for orders. And if we delete them, we're going to forget all of their information and not know about it. And so the database will catch that. If you're like if you're like just going through and deleting old information, it'll catch that you need to remember some of these things. Okay. It is changing. And so now there are a few different ways that things can be tied together. So in this instance, one customer can have a lot of different orders, but each order is only going to have one customer. If you think about it, when you're ordering something from Amazon, the order belongs to you, like you're the only, but you can order a lot of different things, so you'll have a lot of orders that point back to your customer ID, but at the same time, each order that you make, like it's not going to have somebody else's ID on it. Like 2 people didn't make that order; it was just you, and so that's kind of a many-to-one relationship. And so there are a few more examples. Each guest to a party or something might receive a single invitation, but you could invite 2 people on the same invitation, and so each guest has one invitation, but one invitation had multiple guests. Same things with email addresses. It can even be hierarchical. You can have each city has one region, and each region is in one country. Now sometimes with almost any example I give, somebody can come up with an edge case. But the purposes of the database is usually to kind of simplify things. So you can think of random cases, maybe with grandparents or something, where 2 people use the same email address, but it's not it's not a common thing, and so you might treat it as if this is true. The same thing with each region being in one country, you might treat it as being true for this case. Depending on your needs, if you're looking at something where that's particularly important, maybe you won't have that restriction. So that's the most common relationship, and when you're in this case, the thing to remember is the thing that you have a lot of points to the thing that you only have one of, because it means you just have to store that one number, and it's a lot easier because if you don't know how many of them there are going to be, do you have like one? Do you just have a bunch of columns and some of them are empty? Do you have like a column that's like a weird list thing? It's a lot easier to just have the column have exactly one number in it. So going back to the previous one, it'll come up in just a second here. You'll see that it would be kind of confusing if you try to do it the other way around. So instead of having the orders have a customer table, you tried to have the customers have an order table, like would you have like order 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, and then just so you've got 2 right here for customer 2. Would you have like this column have a 1 and this column have a 2 and then a bunch of blank ones? But then how many columns would you have? Or do you have like just a list of numbers in the column? But the computer has a harder time with that, and so it makes everything works out a lot better if you follow the rule of the thing that you have a lot of, point back to the thing that you have one of. The next example we'll do is when there's one of each. So this one is an interesting one to think about because often if there's exactly one of each, you'll put them in the same table, but sometimes that might not be appropriate. The example I've come up with is a driver's license and a person. So each person is going to have at most one driver's license, and each driver's license is going to have, belong to exactly one person. But you might not necessarily have them in the same table. Some users might be allowed to look at like the table of people, but don't actually have access to look at their actual driver's license numbers. So something like that can be to protect people's information. And so they're in separate tables, and so the person looking at it can see that there's like a number pointing to which driver's license they have, and so they can see this person has a driver's license, and we know about it, but maybe that person isn't able to open up the driver's license table and see their actual number. So that sort of thing would be the reason you might do this. Another weird example was that like you can even have foreign keys to the same table. So you could have a people table and a column for like spouse ID, and they'd point to each other. That was just kind of a weird one. So in this case, it doesn't matter as much which one points to which other one. The thing that's probably the most beneficial is you pick one that's dependent on the other. So in this case, it'd be better to have, it would probably be better to have the driver's license reference the person, unless, of course, you have that example I gave. And so, you have the driver's license reference the person because there has to be a person. But it's not much worse to have the person reference the driver's license, particularly in the example I gave, if you need to be sure that the person has one without actually knowing what it is. And the last one is many-to-many. I will talk about it briefly, but it's more complicated than the other two a little bit, and I don't think you will need it for the lab, because the best way to deal with this one is to create a new table. So you'll have maybe 2 different tables. In this case, I've got authors and books. Each author can write a lot of books. Each book can have multiple authors, and so where do you put it? Because as I mentioned before, you have the problem of like lists of references are kind of a problem. And so in this case, what you normally do is you make a join table. And so the join table is going to have, in this case, 2 columns. It's going to have author ID and book ID. And so all it's going to say is, this author wrote that book. This author wrote that book. And so it's just pairs of authors and books. That way, with any author ID, you can look up in the join table all of the book IDs that they're paired with, and they wrote all of those books. Or with any book, you can go to that table and look up all the books and see which authors they're paired with to see who wrote a given book. And so you can look it up both ways. The example that we have here is tasks and tags. And so it's a pretty simple idea, and it's a really simple table here. And this, you'll get all the slides, so you can look through this if you want. There's also, I cite places where you can look at the end if you want to read more about any of these things. And so in this case, you just have tasks, and they have their own IDs, and then information. You have lots more columns here. And then tags, they have an ID and then a name, and you have lots more columns here. And then the join table is just this table that has a task ID and a tag ID. So it says these 2 go together. And so it helps pair things that have many-to-many relationships. But I don't think you will need to do that. I just didn't feel right describing the relationships in tables without mentioning that there is a third one that I don't think you'll need for the lab. And so I talked a little bit earlier about these. So the easiest way to have people enter information into your database is going to be through forms, because the forms can get feedback from the database and can let the user at the time that they're entering the information know that something was invalid or that something was missing that they needed to have. And so you'll be using Microsoft Access or LibreOffice, whichever you'd like. I think the lab is written up so that you can use either. I think it has instructions for both. You'll be creating your form through that, but just as common, HTML forms do the same thing. So anything that you see on a web page or in an app, it's the sort of thing that it's doing. So you're just sending, name, phone number, email, password. It just sends the information, and then it just gets entered into a database. And so if the database has rules that say, the phone number field is required, and you don't send one, it'll probably come back with a notice that says, required field not filled in. Fancy, and they don't even make you leave the page. They just notice that before it even let you submit. And so this is usually the front end on the database for entry. And so there's only one thing left to look at. We've talked about how the database is structured, how you figure out how everything's tied together. We've talked about how you put data in. The last thing to really focus on is how do you get the data back out? And this is the place where it gets the most complicated, and so I've tried to save as much of the time for this as I can. So you're going to be using select queries, and I don't think that I haven't used anything more recent than the 2010 version, but I don't think Microsoft Access has come up with some brilliant way of making this a ton easier. I can't think of one that they could do anyway. But so it has two main components. So it's just a select command, the list of kind of column or field names that you want, and then from, and then you tell it what table you want to grab the information from. So you might, select first name, comma, last name from guests, and get the list of, people who are attending something. And then this last clause. The most common clause is aware. So you might say select first name, comma, last name from guests, where attending equals yes. And so that'll give you the list of people who are coming. Or you might do where attending equals no, and that's the people who aren't coming. And so that's the sort of query that you're going to make. But we'll go through and break down each of the three parts of it, which are going to be the columns you want, the table you want them from, and any other restrictions you have, like certain fields being certain values. And so the first thing to look at is the fields that you want. And there are going to be 4 ways to do it. You can grab all of them. You can grab all of them from you can grab them by name. You can grab all of them from a specific table, or you can grab one from a specific table by a specific name. And so asterisk just means also if you did like select star from guests, where attending equals yes, you might get, instead of just their first name and last name, you might also get their address, their email address, their phone number, everything else that you knew in that table. Name, I already said, when I call them first name and last name. Table dot something. We'll get to, there's ways that you can select things from multiple tables at once. And so if you're selecting, maybe you're selecting customers, and you want to select, instead of selecting guests, you're selecting customers, and you want to select the ID, but you're joining customers and orders together so that you have like the customer data and the order data, and you can select from both. Just say ID. It's unclear because you could mean the customer ID or the order ID. Maybe they both have a column, a field named ID. But if you say customer.id, then it'll know that you want that one. And so that's what you do here. Table.star would mean you'd say like select. You could say in that instance customer.firstname, customer.lastname, and order.star. So that would give you the customer's first name, the customer's last name, and all of the columns from the order. So you get all of the information. It's just shorthand for saying every single column in this table. And so I've introduced there the kind of the concept that you can pull from multiple tables at once. The way that you do that is going to be with joins. And so you have to tell it how to connect the 2 tables. because it has some way to do it. Now, we touched earlier on foreign keys where one table points to another. That's usually how you'll do it. For the customer in the order, you do a join on customer ID, and you see the customer table's ID field, and the order table's customer ID field. So they're going to be the same if that order goes with that customer. And so that's going to kind of dynamically create a new table that has all of the information, and then you kind of select the data from that. And so then these are the various kinds of joins you can do. Inner join is going to be the one that you're going to want to do the most, and so it's the only one that I'll focus on. But if you want to look at the other types, they're all on the board reference. So inner join, what it's going to do is it says, data is only included if joined fields are in both tables. So it's going to take only, it'll only take, if you do that customers and orders join, it will show you all of every customer's orders. But if there's a customer who has never submitted an order, that customer will not show up in the joined field because they don't belong with any of the orders. Whereas one of these outer joins, you might end up with them there and then like a bunch of blank columns for the order. And so this is the default. If you just tell it to join instead of specifying inner join, it'll do an inner join. And so then that when you do that, that just goes where the table name would go. And so going back to the main structure of the query itself, so that would go right here. So instead of like inserting a table name right here, you would like in parentheses say customers join orders, if those are the names of the two tables, and you'd actually say customers.id join orders.customer.id, and it would take those two tables and join them on those fields, and create kind of like one table. The table itself doesn't exist that way in your database. It won't exist that way for future queries, but it puts that data together so that you can pull out columns from both tables, and you can do any number of joins. If you want to then join that, combine data on something else, like item IDs, get like the names of the items they ordered instead of just the item IDs that are maybe that are maybe existing in the orders table. You can tie all of the data back in and do it all in one big select statement. The last thing we need to look at with these before we go to questions, and I'm sure there will be some, is the clauses that you can stick on the end. I already mentioned the where clause, and using that you can do things like saying a certain column has to have a certain value. To select it, you could say like, let's say it's a tax database, and you want to select all users where tax owed is greater than 0. You can do that too, and so you can do like any sort of comparisons greater than, less than, equal to are good for numbers. You can usually use them with text too. It'll just treat it as if you mean alphabetical order. And so the where is definitely the most common filter used here. You can also do group by. So you pick certain columns and you say like all of the records that you pulled back, if they have the same values for these 3 columns. So maybe here's 3 columns that or any number, but say it's 3, and in this case it's address, city, state. So you're saying group all of the people who live at the same address into the same record that you're pulling back. Like I don't need one for every single person. I just need one for every single address. And so it'll group all of those together. It'll kind of combine them into the same record. Having is pretty much like where, only it happens after the group by. So it's just the order where it happens. So the where picks which records are selected, and then those selected records are done with group by, and then the having filters the group by. That's just if you want to have a really complicated query that has like all of these things in it. usually you're only going to use one or two of these things. You're not going to have a whole stack of using all of these things. I can't even, I would give you an example of a case where you might do that, but I actually can't think of one. I'm sure that somebody has encountered one in their lifetime, but I have not. And then order by just sorts things, so maybe the same thing as the guests, but maybe you want to give them kind of in a specific order, and so you might do select first name and last name from guests, order by last name. That's going to return to you a list of records, but they're going to be alphabetized by last name, which can be convenient depending on what you're trying to do. And so those are the main features of what you're going to be doing. The rest of the slides are just going to be references. So the last 15 minutes or so, I know that there are going to be parts of that didn't make sense. I just don't know which parts they are. So anybody who has any questions, feel free. Yes?
Where do the clauses go?
They go at the end of the query. So if you do, this lags so much. So it'll do like select and then the columns and then from, yeah. So you do select and then the columns that you want. And then from and then the table. And then the clauses go here. So you'd say maybe like order by last name. Would go right there. Order by and then last name just goes at the end of the query. It's only wrapped onto the line because I didn't want to decrease font size.
For the references, do you find it like at the common part of the slides, or?
No, they're on their own slides.
Oh.
And so the number, they aren't appearing properly on the slides, but the number in brackets means like if you just count the references, there's only like 7 of them. If you count, like if it says 3, go to the third reference. That's the one that I'm referencing there. And so the slide itself should say like where you get information related to that. And I cite, I mean, they're not like paper writing sources. A couple times you cite somebody's blog just because they have an effective explanation. But a few of them are actually, official Microsoft, like this is how you use Access sorts of pages. And I try to use the same terminology that they use. So in most cases, if you Google search something using the terminology in here, you should find the right thing. A couple of places I might have slipped up and used like other people's terminology, but I tried to use Microsoft's. So the next lecture, we're actually going to try to do some of this. We'll create a database, create a few tables, link them together, and show how to do all of that, which is what you'll be doing in your lab. I'm almost 90% sure it's a lab.
Are you grading it?
I don't know. I don't think I am, which is why I'm 90% sure it's a lab.
What? It's a lab.
It's a lab, right?
No, it's not, dude.
Okay.
One of the Python ones. It's like about this. It's an extra lab. And then
Oh yeah,
there's a
there's
Python
also a
lab.
LaTeX lab, but that one's I think optional.
Isn't like extra credit lab? Oh yeah, you talked about the text, right? And like, was that like, that wasn't recorded, right?
I hadn't figured out how to record things yet.
Oh.
So yeah, if anybody has any more questions, feel free. Otherwise, class is over, and I'll stick around until people are done just answering questions if anybody has any.
Is this gonna be shared to us like this YouTube video?
I'm gonna try to. I think